Hi, this is Jessica Dunn, and we're going to discuss net present value profiles. Net present value profiles are graphs that depict a project's net present value for different discount rates. So the first step is to develop a number of discount rate and net present value coordinates and then graph them. So let's do this for the same example that we've been working on. So project A costs $42,000 and yields $14,000 for 5 years. Project B costs $45,000, returns $28,000 in year 1, $12,000 in year 2, and $10,000 in years 3 through 5. So assuming these different discount rates, let's calculate our net present values. So we've already done it for 10%. We did that a few lessons ago. So for project A, the net present value at 10% was 11,071, and for project B, it was 10,924. We know that the internal rate of return for project A is 19.9%, so that would be a 0. And for project B, the internal rate of return was 21.7%, so that's also a 0. So let's calculate our net present values for these different discount rates. So the first step is to put the cash flows into our cash flow register. So I'm going to clear this out. Our cash flow at time period 0 for project A was $42,000 cost. It's a negative. And it returns $14,000 for 5 years. So now we push net present value. Let's keep our discount rate at 0 so we can see what the net present value of the project is at a discount rate of 0. And we get 28,000. So let's circle back through this and we'll enter in a discount rate of 21.7 so we can get this side of the table filled out. And we get a negative $1,650.46. So let's plug that into our table. We have a $28,000 net present value at a discount rate of 0%. And we have a negative $1,650 net present value at a discount rate of 21.7. So now let's look at project B. So let's open our cash flow register and then second clear work. Project B costs $45,000, returns $28,000 in year 1. It returns $12,000 in year 2 and $10,000 for the next 3 years. So push the net present value button. For 0, let's see what we get. We get $25,000 net present value. And let's see what we get for 19.9% because that's our only other blank. And we get $1,375.76. So let's go ahead and plug this in. Now obviously these are rounded here. Our internal rates of return were longer than that. So if you were to actually put in 19.9, you'll get something other than 0. But if you put in the full discount rate, you'll get 0. So we had 25,000 here, and for 19.9%, we had 1,375. So now we need to graph these numbers. Now, typically you would do this in Excel, where you could put in 0 to 25% in 0.5% increments, and then graph them. But this will get you the same idea. So when we graph these, we see that project A is better than project B as long as the discount rate is greater than 10.7%. If the cost of capital is greater than 10.7%, project B is better than project A. Below 21.7% discount rate, project B is unacceptable. So this shows us different scenarios for different projects and for different cost of capitals. Now, if you wanted to actually calculate what this crossover rate is, because I just told you it's 10.7%, but I didn't tell you how to calculate that 10.7%. If we want to calculate that, then we calculate the differences in the cash flows between these projects. we enter in the differences in the cash flow register and push internal rate of return, and that will tell you the crossover rate. So it doesn't matter if you subtract A from B or B from A, as long as you're consistent. So we can go ahead and do that. For project A, I'm going to scroll back to the previous slide so we can see. For project A, it was $42,000, and project B was $45,000 cost. So if we were to say, let me scroll forward. I didn't realize I had a slide for it. If we were to say, let's say cash flow 0, let's do A minus B. So we have a negative 42,000 minus a negative 45,000. That gives us a $3,000 cash flow at time period 0. Cash flow at time period 1, we have to do A minus B again. So A minus B is what we're doing. We have 14,000 minus 28,000 to give us a negative 14,000. Cash flow at time period 2, we have 14,000 minus 12,000. So that gives us a $2,000 return. Cash flow 3, we have 14,000 minus 10,000. So we have a 4,000 return, and that occurs 3 times. Let's plug this into our cash flow register and calculate the internal rate of return to get the crossover rate. So first step, let's push the cash flow register, then second, clear work to get everything erased. We have a $3,000 initial cash flow. Enter to save. Cash flow at time period 1 is a negative 14,000. Occurs once. Cash flow at time period 2 is 2,000. Occurs once. And cash flow at time period 3 is 4,000. And that occurs 3 times. So I'm going to push the IRR button and compute, and we get 10.72%. So that's the crossover rate for the net present value profile, and that tells you at what discount rate we see the swap in project preference. So here we see this crossover rate is 10.72%. So at a cost of capital less than 10.72%, project A is better. But if the cost of capital is greater than 10.72%, project B is better.